Gonna point out some things that are kind of important as far as these systems of equations. We've already discussed them briefly, but this will, I think, make it a little bit more clear. So one of the points that they want to make here is that you can multiply these lines by anything you need to, and you can multiply one line or both. So if we look at this one, we have this decision if we want to eliminate the x's or the y's. And again, there's literally an infinity of ways to do this. So to me, I think the easiest thing to do would be to multiply the top by 4 and the bottom line by 3 and eliminate those y's. But again, there's an infinity of ways you can do this. You do not have to choose this one. Excuse me. But obviously I'm going for those y's. So I get 43x equals 43. So obviously x is going to equal 1. Again, I'm just going to grab one of these equations and sub x in for 1 to see what I get. So 4 plus 3y equals 10. Subtract 4 from each side. And y is going to equal 2. So now what I'll do is grab the other line and I'll plug in both, right? So 9 times 1 minus 4 times 2, and that should equal 1, and 9 minus 8 does equal 1. So I feel pretty good about that. The ordered pair that these meet at is indeed going to be 1, 2. So, like I said, that was just sort of one of the things I wanted you to see here. One of the next things, we have another word problem, so just a little bit more practice on word problems. And again, just going through the process, I think, consistently doing it the same each time. First, we're going to define the variables. And again, I'm just going to read the question: how many containers of blue paint and how many containers of silver paint did the art club buy? So I know that B is going to be the number of blue paint. And I will go ahead and make S the number of silver paint. And now we'll go ahead and read the whole question. Again, and it's just my preference to just figure out what the variables are first, but you can read the whole thing and then do the variables. It's up to you. So blue paint comes in 5-ounce containers costing $2 per container. Containers of silver had 2 ounces and cost $3. The art club spent $56 and bought 74 ounces of paint. So $5 for, 5 ounces of blue paint plus 2 ounces of silver paint equals 74 ounces. And $2 for a blue container and $3 for a silver container equal $56. So a couple things we're doing here. Now again, it's just a matter of if you want to simplify to eliminate the B's or the S's. I'm going to go ahead and I'm going to multiply the top by 3 and the bottom by -2. So I will get 15B plus 6S equals 216. I will get -4B minus 6S. My S's look like 5s there, sorry. Equals -112. So when I combine those, I'll get 11B. My S's will eliminate. And here it looks like I'm going to get 114. I don't know. 210. Yeah, this is not going to be 216. That's going to be wrong there, so I apologize. 3 times 7 is 210, plus 12 is going to be 222. So this is going to be 222. This whole thing is falling apart on me now. So this is 222, and this is going to be 110. So when I divide by 11, B is going to equal 10. So at this point, I'm going to go ahead and see if I can at least get a little bit more white room to work So kind of a bummer that I have all this stuff here. But anyway, so solving it, I get b equals 10. So now I can go back over into one of these two equations, and you can see I've kind of screwed this up and got this in the way now, which is kind of a bummer. But my equation is 5b plus 2s. So I'll take that 5b plus 2s and I will plug in 10 for b and solve. So I get 50 plus 2s equals 74. Subtract 50 from each side, I get 2s equals 24. So s is going to equal 12. So I have 12 cans of the silver paint and 10 cans of the blue paint. But again, I'm going to go into this last equation, which is 2b. So 2 times 10 plus 3s, so 3 times 12, to make sure that it equals 56. And I get 20 plus 36 equals 56. So that is correct. 10 blue containers and 12 silver containers. And again, unfortunately, I deleted that. And made it messy, so I apologize for that. Okay, so moving along, 6103, it says Tracy's team was given the following system by their teacher. So we have this system. It says use elimination and see what happens. Do these equations represent the same line? How can you tell? If you've not already done so, prove that they have the same line. So we're going to be introduced to another thing that we've kind of discussed, is that when we have we have a system of equations. We have two lines. It's either going to meet at one point, it's going to be parallel and never touch, or it will coincide and be the same line twice. So I suspect that we're going to see something along the lines of one of these three options. So let's see what we have here. We're going to multiply this by -2, the bottom by -2. We get 10x plus 4y equals -8. I get -10x minus 4y equals -20, and I get 0 equals -28, which is false. So I think that means that I am looking at option 2 here. I think I have parallel lines. They're going to go forever and never touch. So let's see if that's the case. It asks us to solve both of these things for y and compare them in graphing form. So y equals -5/2 x minus 2. Over here we'll subtract 5x. We get 2y equals -5x plus 10 divided by 2, and y equals -5/2 x plus 5. So you can see, yeah, they are parallel lines. They have the same slope but different y-intercepts, so they will run next to each other forever and never touch. Alrighty, let's close this and then open it and finish off section 633. So 633 says the equations of two lines are given below. A table of solutions for the first equation has been started for you. It just kind of makes it easier. You can see it's adding 5. Every time the x goes up 2, the y goes up 5. So if it's a line, that should continue. So I can just keep adding 5 there. This one, I have the y-intercept of -2. So if I plug 0 in for x, and then the slope, it goes up 2.5 each time. So this will go to 0.5, and this will go to 3. And then I can subtract 2.5 each time and see what I get here. So if I subtract 2.5, I get -4.5, and then I get -7 and -9.5. Yeah, I don't know what I was thinking here. This should be 14 if I add 5 each time. That was weird. Okay, it says complete the tables for the given equations. Using the tables, can you readily find the point of intersection of these two lines? I do not seem to be able to, and I don't know what I'm screwing up here, but if I Add 2.5 each time. Yeah, I'm not really seeing the intersection, and I'm kind of missing it. So I don't know if I'm supposed to be seeing something I'm not or what. But I'm going to go ahead and plot these points down and plot these points, and we'll answer questions B and C. We'll graph both lines, and without using algebra, we'll see if we can get the equation, and we'll predict the solution, and then we'll solve them algebraically and see if our prediction was correct. So let me pause this and set this up. There's another error. I see what I did here is I used the slope by 2.5, but it only goes, the y only goes by 2.5 when the x goes by 1. The x is going by 2, so the y needs to be going by 5. So I'm glad I caught that before I got too far, but I wish I had caught it earlier. So I'll make another comment about another error that I found that I figured out. So frustrating. Anyways, so like I said, if it goes up 2.5 per 1, it goes up 5 per 2. So this will be at 3. This will be at 8. And if I'm going up 5 in this direction, I'm going down 5 in this direction. So -7, -12, and -17. So what we're looking at here is, when do I think these things will intersect? I quite frankly don't think they will intersect. It looks like that every time I go up 5, I go over 2. So I think we're going to have some parallel lines here. So now I will pause this and graph them, and we'll see. Desmos and graph these two lines, and you can see that they are indeed parallel lines that are going to run forever and not touch. All right, so continue. Oh, it says solve them algebraically and verify. So if we solve these algebraically, what we should come up with is the idea that that we get something like 5 equals 2 or 0 equals 8, or just a false statement, right? So I'm going to use substitution. This looks like it's set up for substitution. I'm going to grab this equation here, and I'm going to substitute this y with 5/2 x minus 2 minus 5x equals 8, and I will just solve that. So as I distribute, that will cancel. I'll get 5x minus 4 minus 5x equals 8. You can see these eliminate. I get -4 equals 8, which is false. And again, that's what we expect. We expect a false statement, which lets me know that those lines are parallel. So that's what we have there. All right, and then finally on 6-105, let's see if I hopefully won't screw this up again. So this one obviously is adding by 5 each way. So that's going to be -2. That's going to be 3, and that'll be 8. Now over here, I won't make the same mistake this time. I know that it's going by 2.5 per 1, so it's going by 5 per 2. So here I will add 5, add 5, and add 5, and in this direction I'll subtract 5. I'm struggling here. And you can see what kind of, by the tables, they're the same. So I think these lines are going to coincide. So it asked me to graph both those lines, so I will do that. And then I will come back and fix this. So let me see here. Yeah, I think I can just go into Desmos real quick. So 10x minus 4y equals 8. So 10x minus 4y. And you can see here that what we get is we get the same line twice. So there you go. We were correct. And now if we run back over here, we would expect, if we solve these things, to get a true statement, something like 5 equals 5 or 0 equals 0. Again, I'm going to use substitution. So I'm going to take this equation, 10x minus 4, and I will substitute 5/2 x minus 2 in for the y equals 8. So I have the whole equation and just substituted. Again, I will distribute this 4. And again, I get, because of cross canceling, this will be pretty simple. I'm going to get minus 10x plus 8 equals 8. When I simplify, I get 8 equals 8, which is a true statement. And again, when we get a true statement, we expect to see lines that coincide. So a couple things in this lesson. One, again, was just reiterating the point that you can multiply both lines by different things, if that helps you use elimination. And then also the idea of, when we have a parallel line, we'll have a false statement. -4 doesn't equal 8. That's false. So we have a parallel line. And then if we have a true statement, we'll get coinciding. 8 does equal 8. That is true. So these lines coincide. They're the same.